Alright, we're back at the gas law problems, and we're looking at the combined gas law, and we're going to do problems 6, 7, 8, and 9 here. So again, we're working with, oops, let me fix that. Working with the problem, or the formula, P1 V1 over T1 equals P2 V2 over T2. And again, let's go ahead and do our little table here. P1 V1 T1, P2 V2 T2. Okay, at 45 degrees Celsius, the volume of certain gas is 27.5 liters. So we know that's 27.5, and the pressure is 210. Now, temperature is 45 C, so we got to go ahead and change that to Kelvin. So Kelvin equals the Celsius, which is 45, plus 273, so that equals 318. And I think I'm off a little bit, so let's bring that in. So 318, so temperature 1's 318. What is the volume? So we don't know what this is. At standard temperature, 273, and a pressure of 310 kilopascals. Alright, so we can go ahead with this one, and we can plug in. P1 is 210. V1 is going to be 27.5. 27.5. T1 is 318. P2, we have 310. We don't know what V2 is, and we know what T2 is 273. So this is the classic cross multiply and then divide. So this times this times this equals this times that, and then you would have to divide the value of these two into this particular group there. I'm not going to do all the math here, but I'll go ahead and do the cross multiplication. So you'd have V2 times 310 times 318 equals 273 times 210 times 27.5. And I'll let you guys go ahead and do the math on that. And so you'd have this quantity divided by this quantity. So we're looking for V2, and let's go ahead and look and see how many significant figs. It's like 3, 3, 2, 2, so I can answer it can only have 2. So if you do the math, volume 2 is going to equal approximately 16 liters. So that's problem 6. Let's look at problem 7. And the pressure of a gas sample, and let's go ahead and write the formula again here. P1 V1 over T1 equals P2 V2 over T2. Might as well make our table. P1 V1 T1 P2 V2 T2. Now we can go ahead, let's read it. We've got a pressure of a sample of gas was 97.8 kilopascals. So we know the pressure is 97.8, and the volume was equals 3.75. If the gas occupied a container with a volume of 8.00, if the gas occupied a container with a volume of 8.00, what would the pressure in the container be? So we don't know that. This is kind of a goofy problem a little bit, because they're not saying anything about the temperature. It says the pressure, the volume of the gas. So we're going to assume temperature to be constant. So we're going to take that right out of there. So we got pressure 1, 97.8, volume 1, 3.75, and we don't know what pressure 2 is, but we know that it would be volume of 8.00 here. So again, multiply these two, divide that by that, and let's go ahead and look at sig figs. Looks like we got 3, 3, and 3. So if we do the math, pressure equals 45.8, and we're working kPa, kilopascals there. So that's problem number 7. All right, let's look at problem number 8. I know it's going to sound redundant, but we know P1 V1 over T1 equals P2 V2 over T2. Let's go ahead and write this out again. I know this is redundant, but sometimes slower, as my dad used to say, slower is faster. So number 8, isothermal expansion refers to allowing a gas to expand while keeping the temperature constant. Well, if we're going to keep temperature constant, we don't need to worry about that. If the gas originally at 97 kilopascals is allowed to expand from 0.025 to 182 liters, what is the new pressure? Alright, pretty straightforward. So P1 is 97, V1 is 0.25. We don't know what P2 is, but we do know that the new volume is 182. So it looks like we're increasing the volume by a whole bunch. If we're keeping temperature constant, we would expect the pressure probably to fall off. And let's look at sig figs here. We got 2, 2, and 3, so our answer will have to have 2. So multiply these two, divide by that. P2 equals 0.13 kilopascals on there, kPa on there. And it kind of makes sense because we're really increasing the whole idea of a larger and larger volume. All right, let's look at the last one, number 9. Again, V1, I think I put P1 V1 over T1 equals P2 V2 over T2. So P1 V1 T1, P2 V2, and T2. So we got a gas initially at a pressure of 225 kilopascal, so we've got this, 225, and a temperature of 245 Kelvin, so we're good there. We don't need to change it because it's already in Kelvin. In a container, that's 4.5 liters. Okay, so we've got that. If the gas is compressed to a volume of 2.1 liters and the temperature changes to 275 Kelvin, so we don't need to change anything, well, what's the new pressure? Whoops. So we got 5 of our variables, so we can go ahead and do the substitution. And before we even do that, let's look at sig figs 3, 2, 3, 2, 3. So our answer can only have 2 sig figs on that one. This one I might, seeing it's the last one, I might carry out some of the mathematical steps on here. So P1, 225, V1 is 4.5 divided by temperature 1, 245, equals, we don't know what P2 is. We know what volume 2 is. It's 2.1. And temperature 2 is 275. Again, it's the classic cross multiply and divide. So let's go ahead and do this. So cross multiply. So it's P2 times 2.1 times 245 equals 225 times 4.5 times 275. So let's go P2, and we'll do the math since it's the last one here. So 2.1 times 245 equals 514.5. 514.5. Guess I'm going to remove that up a touch. And then let's go ahead and do these three. 225 times 4.5 times 275 equals, that ends up being a pretty big number. 278,437.5. I think I've got that right there. 278,437.5. Okay. So at this point, take this value, divide by that. So I'll go ahead and do that. Divide by 514.5. 514.5 equals 541. So P2 equals 541. And we're talking about sig figs. And make sure we're pretty good there. Yeah. So it looks like we got 2 and 2, so we can have only two significant figures. So P2 equals 540 kilopascals there. And make sure, that's PA on there. So make sure you always include your units. All right, so that takes care of the combined gas laws.